We are honored to have architect Aditya Dua. He is an alumnus of the prestigious National Institute of Technology in Jaipur. He has been a valued member of the dynamic team at Amit Khanna Design Associates, where he has been making significant contributions to various architectural projects. Dua's professional journey has been marked by his involvement in the diverse range of projects spanning the realms of residential, commercial, educational, and industrial architecture. Architect Dua will talk on fenestration system for high-rise building. So let's welcome Aditya.
The fenestration systems that we have in high-rise buildings today. To start with, so I mean, just going to the basics that, what is fenestration? So fenestration is a term that is used in architecture and building construction, which refers to the design, construction, and arrangement of windows and other kinds of openings in a building. So, fenestration, it's a fundamental aspect of any building design because it directly affects the building's aesthetics, the energy efficiency, the natural light intake, the ventilation levels, and, the overall comfort of its occupants. Now, why is fenestration necessary in any sort of building, be it a modern building or be it a historic building? I'm sure you are all familiar with this image. This is the Hawa Mahal in Jaipur. And here the fenestration serves a very different purpose. The windows are a part of the Jarokha design, which is a very iconic facade in itself. So, I mean, going point by point. So natural light, yes, well-designed fenestration allows natural light to enter the building, and it reduces the need for artificial lighting during daytime. Then, as I said earlier, fenestration also allows for a good ventilation, air ventilation throughout the building, which, through which fresh air enters and circulates within the building, which again reduces the use of mechanical means of, ventilating and keeping the climate control inside the building's mass. Then also it provides thermal insulation. So as you know, double glazed windows, in colder areas, in colder countries, it provides a way to retain the heat that you get from the sun. The arrangement of windows and openings on a building facade, they also affect the visual and aesthetic appeal of the building as well. Now, types of fenestration, we are all aware about what's a fenestration. So there are 4 basic types if we talk about that. First is windows. So, anything, any puncture inside a building on a vertical surface, which brings in light, which you can open and have a view through is usually called as a window. Now, windows are essential architecture elements that provide light, ventilation again, and, they offer a visual connection to the outdoors of the building. Another important and a very interesting type of fenestration is a skylight. These, you see in residences or in cafes or restaurants, because it's a window and it's a series of windows which are installed in any sort of a roof of a building. And unlike traditional windows, these are positioned horizontally, which allow natural light to enter indoor spaces from the above. Doors, definitely any way to which connects a building's inside to the external through a doorway, something through which you can enter the building. That's very straightforward. What we are interested and what I'll be talking about is curtain wall or a structural glazing that we have in case of a high-rise building. Now, you must have seen around that in case of a high-rise building, you don't see normal windows usually. The whole facade is clad with glass. And although it seems like, that the whole thing acts like a window, but there's a lot of detailing, there are a lot of components that go into making something, which can stand as tall as 100 floors in, buildings across the world. A curtain wall is basically it's an outer covering of a building's facade. And unlike traditional walls, curtain walls are designed to support only their own weight, and they withstand wind loads, seismic forces, and other environmental factors. They do not carry the structural load of the building in any sense, but they are supported by the building's internal main structure itself. Now, if you talk about types of curtain wall. There are basically all sorts of, glass facades that are that encompass a high-rise building, or buildings which are made today, which are usually office spaces, and these big residential or mixed-use towers. So they can be categorized basically into three options. So there's a semi-unitized system, there is a unitized system, and then there is a spider glass curtain wall. So I'll just show you an animated graphic that will sort of take you through how these systems work. So a semi-unitized system or a stick-built curtain wall, they are assembled piece by piece on site. All the components of a window, they're all manufactured in a factory, but piece by piece they're brought to site. The mullions and transoms are all installed first on the structure of the building, and by this the glass is uh, cladded on the site itself. A unitized curtain wall is different from a semi-unitized curtain wall in a way that a unitized wall is all manufactured inside a factory itself. So this can be classified as a prefabricated product. These are assembled into large units or panels in the factory, and they are then transported to the site wherever they are meant to be installed, and they are installed as complete units. So in a way, unitized systems offer faster installation, and they reduce on-site labor. They create a healthy working environment because there is more space to store the building materials properly. Obviously, having a faster construction time saves a lot of money for the clients as well. The third type is a spider glass curtain wall. So these have been around for a very long while in India. They use spider fittings, which are basically metal bolts that grip the edges of the glass panels, and this system creates a frameless, transparent appearance. So since the panels are stuck to the building using a external bolt, which appears like a spider, and hence the name, they don't have a frame, right? So you get a very seamless looking appearance of the building. So these offer architects the freedom to design expansive glass surfaces with minimal visible supports. Recently, semi-unitized systems and unitized systems have also been introduced, into the in the markets in India. We ourselves have been, working with these systems in a couple of our projects. We've been working on some office buildings in Delhi. And we prefer, in one of the completed projects that we've done in Central Delhi, we have used a unitized system wherein the glass was fabricated at a factory and then brought to site by trucks and then installed. Unitized systems also, it's a double glaze unit system. We can specify if we want to use a low E glass in that, and they also have all the technology that has helped make them fire safe as well, all the thermal breaks and the gaskets that, all the fittings that they use along with the glass inside the frame itself, that we have been using for a couple of our projects. And the graphic that you can see, these prefabricated panels, so to say, they come at site and they're just clipped onto each other. And that's how, this sort of encompasses the building completely. Moving on, what I want to focus on and what we are particularly interested in, is in the innovation in fenestrations for a more sustainable design, for upcoming buildings, for the buildings of the future, which we like to call as smart buildings. How do we actually make them smart? So there are many ways to go about it. There is energy efficient glazing, which is a glass with low E value, which sort of retains a lot of natural light that comes from the sun, but it sort of resists the heat coming inside, so that you can keep the insides of the building cool. Then there are thermal breaks. Thermal breaks is a system inside the glazing system. It sort of stops any sort of heat gain, and also acts as a fire safety unit, which sort of stops fire going across the floors. Now we've always had passive shading systems. Passive shading systems, by that I mean that if you integrate some sort of projections or a shading device, which sort of stays very static, and it naturally sort of, by the virtue of its dimension, it shades the the glass of the building. The most interesting development that we have been looking to work with in one of our recent projects is building integrated photovoltaics. So what this means is that the building, if it's a high-rise building, we have a lot of vertical surface area. Now, what we intend to do in the future is that this surface area, rather than make it just a component where you can sort of get natural light from inside and then you have a view outside, it's a great opportunity to harness a lot of solar energy from these large surfaces. So BIPV, or building integrated photovoltaics, it refers to the integration of solar energy harvesting features directly into the building envelope. Such as, we have solar panels on the rooftops. What we are talking about is putting solar panels on the vertical faces of the building. Now, BIPV seamlessly merges solar technology with the building's architecture. This integration provides both the functionality of a building material and the capability to generate electricity from sunlight. Now, since we've been exploring this, in one of our projects, this system sort of works both ways. You can either, choose to store this energy and then use it at a time of need, and you can also choose to, work it as a combined system with the direct supply that you get from the municipal corporations. And now this image, as you can see, this is sort of one way. This is more of a retrofit. The image that you saw earlier, here the panels have been integrated into the glazing of the building. So in this image that you see, on the left side, you have the interior of the building. On the right side, you have the exterior. And having a certain gap between the main window that you have inside and these BIPV panels, you also get a thermal insulation buffer by the virtue of the gap between these two surfaces. And this is how they look. If you have a solar panel which is sort of stuck to the glazing of the building, this is how it looks from the inside. Now, BIPV systems can be designed to blend seamlessly, to have a good aesthetical value of the facade. What also BIPV does is that it is utilizing the existing surfaces of a building, which would in any other case would have been a normal panel. You are now using it to generate energy, so you're not really using up any extra space inside the building. Now, BIPV obviously can contribute to overall energy efficiency of a building by providing shading. As you can see, these cells that you have in the glazing, they also provide a natural shading to the inside of a building, and they also help in reducing the heat gain. What we are also exploring that, in order to cut the solar gain even more, let's say in the Northern Hemisphere, and particularly in Delhi, where the climate is very hot during some months. So we want to take it a step further and add some sort of active shading, these sort of vertical fins that integrate with the glazings, that have been installed on the facade of a building. The challenge that we usually face is that, there are multiple vendors who will do a lot of stuff. Someone who's doing these windows is different. Someone who's doing these fins is a different person. So getting a solution, a technological and logistical solution wherein, all of this integrates and can be done by the same agency. It is very, helpful for the clients and the architects as well to have the best solution possible, for these upcoming buildings. Now, these fin elements, they are designed to provide shading and reduce solar heat gain again, which seamlessly integrate with the facade of the building. They serve multiple purposes like, controlling natural light, enhancing energy efficiency, and improving occupant effort.
Thank you, Aditya, for that exciting submission on fenestration system for high-rise buildings.